In this video, I'm going to show you a strategy to help you deal with piecewise defined functions. Né? It's a very easy method that you need to adapt, and then you'll find all these questions very easy. I call it the number line strategy of dealing with piecewise functions. Okay, so let's start with the first one. So this is our piecewise function, right? And then these are our critical values. So the only critical value that we have there is 1. So what you do, you draw a number line. Then you show that this is 1. And then you do dotted lines. The reason why I do dotted lines is because 1 is excluded in both. So it's dotted line shows that it's excluded. If it was included, I'd use solid lines. Né? Perfect. And then they say x is less than 1. So it's this side. The function is dead. So on this side, I have sine pi x. And then for x bigger than 1, which is on our, it's on our what? It's on our right. So it's this one. So it's 2 to the power x squared. Right. Now, if I have that, I can answer all the questions. They say I must find f at 1, which is the first question. They want me to find the y value when x is 1. So from here, as we discussed, we said x cannot be 1. It's just the critical value, which means f at 1 does not exist. Ne? Does not exist. Because the x value, there's no x value of equals to 1, basically. Okay. Sharp. Now let's look at B. On B, we are looking for limit as x approaches 0. Let's check where our 0 is. Our 0 is somewhere here, right? Let's say 0 is there. Then we want to know what happens as we approach 0. Remember, for a limit to, remember this is a full limit. For a limit to exist, its partial limits must be equal. By partial limits, I mean limit from the left and limit from the right must be the same. But because 0 is here, as I'm moving from the right, approaching 0, I'm approaching this function. Also, as I'm moving from left, approaching 0, I'm approaching that function, which means I can therefore conclude that limit as x approaches 0 of this function is basically, I can substitute there, which is sine pi times 0, right? Which becomes sine 0. Sine 0, which is 0. Right. So the answer for B would be 0, ladies and gentlemen. Right. Now let's check C. On C, we have limit as x approaches 1. So I'm going to check both. We're going to check both the left and the right hand limit to see if it exists indeed. So limit as x approaches 1 from the left of f of x. We want to see the answer. And then we also need limit as x approaches 1 from the right of f of x. Right, as we approach 1 from the left, basically, we are approaching this function because we are on this side of this, we're on the side of this function. So here, basically, we're going to have sine, we substitute into that one, pi times 1, which is sine pi. But we know that sine pi is 0. Remember, pi, you think of it as 180. So sine 180 is 0. Okay, now let's come this side. If I'm approaching 1 from the right, I'm basically having 2 to the power 1 squared. Why? Because as I'm approaching there, it means I'm moving on this graph. So I must substitute on the graph where I'm moving on. So the limit of f of x as x approaches 1 from the right is that, right? And then when you're working with the exponent and like that, you work downwards. Ne? So the 2 is still there. It's going to be 1 squared, which is 1. And then the answer is 2. All right. Does that? Now let's check the second question. Let's check the second question. Yeah, pardon me about that, ladies and gents. I think I've caught some flu, but yeah, we're soldiering on. We're soldiering on. So if you haven't hit the like button, please do so, as this helps my channel grow and help more people. Okay, awesome. So now let's look at this piecewise function here, right? So this one has critical values -2, -1, 2, and 2. Okay, so I'm going to draw my number line, right? We are going to say, okay, we need -2 there. Then what is the next one? -1. Then what is the next one? 2, right? You remember you list them in ascending order. They must be listed in ascending order, right? And then now this is what I'm going to do. And -2 is not included, so I use dotted lines. Ne? So those are dotted lines. And then -1 is not included, so still dotted lines. And then we have 2 as dotted lines as well. But on the last one, they say 2 is also included for t bigger than 2. So which means here I'll just say included if we are coming from this side. Ne? Included. So the 2 is included here on this part. Ne? Now you need to list your function. They say t less than -2 is here. So here you have t squared. Between -1 and 2, you have this guys, which is the t plus 6 over t squared minus t. And then for 2 and above is 3t minus 2. 3t minus 2. Right. Now let's start with the first question. They need us to find f at -3 over 2, which is basically f at -1.5, right? But remember 1.5 is somewhere here. So you don't know whether to go there or there. So the limit does not what? Does not exist. Why? Because the value here, they put it where there's no function. So we cannot really make any prediction there or approximation. Right. That's the first one. Then let's go to B now. Let's go to B. Remember, I need my... Okay, I can do this actually. Wait. Let's take this. Not that. Let's take this and then do this. And then move it. Okay. Now we can proceed actually. Let's check B. I need f at 2. Remember 2 is here. And 2 is included this side, but excluded that side. So let's show that this one is excluded, the 2, right? So we're going to use that. So we're looking at f at 2. We take whatever the positive 2 st exists on, and then we substitute there. So I can see that 2 exists on the right of 2. So is this function, which is basically 2, 3, 2 minus 2, which is basically 4. All right. Now we can go to C. So on C, they say f at 1.5. 1.5 lies somewhere there, right? 1.5 lies somewhere there. So I need to put 1.5 on those things. So it's going to be 1.5 plus 6 over 1.5 squared minus 1.5, which is giving us, let's see, how much will that give us? Okay. Let us see here. That gives us 10. So the limit for C, its value is 10. Okay. We're going to do D. Let's check D. Oh, sorry. Remember the 2 is included there, right? So now let's do D. On D, they want us to get F at T, the Sx approaches -2. Sharp. So remember, for the limit to exist, the value of the limit from the left must be exactly as the limit from the right, but there's nothing here. So we can easily tell that at -2, the limit does not exist. Limit does not exist. Okay. Now let's do E. E, they want us to find the limit as x approaches -1 from the right. So approaching -1, but we're coming from where? We're coming from the right. So we're coming from this way. We're approaching -1. So it means this is the most useful equation we're going to use, right? We're going to say equals to -1 plus 6, -1 squared minus -1, which is 5/2. That was your E, right? Now let's do F and G and finish. F, limit S T approaches 2. So I need to check for this left-hand limit and the right-hand limit. Right. Okay. So let me create space actually for myself here. Okay. So you have D there, which is, let's see. I mean, you have F, not D, F, which is the limit ST approaches 2. So we need to do limit ST approaches 2 from right of F at T. Then we need to do limit ST approaches 2 from the left of F at T. Right. Okay, let's see here. So here, ladies and gents, we need 2 from the right. 2 from the right. We need to substitute on this one, right? So it's going to be 2, 2 minus 2. Right. I feel like I'm missing something important. Let's see, let's see. Let's see, ladies and gents. Let's see, let's see, let's see. Oh, here, this is a 3. Sorry about that. So that's a 3. So it's 6 minus 2, which is 4. Now from the left, we're approaching this one. So we can substitute quickly, which will give us t, which is 2 plus 6 over 2 squared minus 2, which becomes 8 over 2, which becomes 4. Therefore, limit of f of x as x approaches 2 is equals to 4. Now let's do the last one. The last one, they want us to do what? Let's see. T is approaching 0. Let's see. So if it's approaching 0, 0, remember, is in between -1 and 2. So we're somewhere there. So it's going to be t plus 6 over t squared minus t. Then it's going to be limit as t approaches 0. Here you can see that, guys, if I were to direct substitute, it's going to be 0 plus 6 over 0 squared minus 0, which is 6 over 0, which is no solution. Therefore, limit does not exist. Right. And that's it with this video, ladies and gentlemen. I'm hoping it was helpful. If you found it helpful, don't forget to like, share, and subscribe. Thank you very much.